Hello. Today's success criteria is going to be solving a basic logarithmic or exponential equation. So there's two types of equations that we're going to be working with today. Luckily, exponential functions and logarithmic functions are inverses of one another. So we kind of use one to solve the other. So I have a series of examples. I did want to start off with kind of what I just said. The big idea here is logarithmic functions and exponential functions are inverses. You can use if I give you an equation with logs, we use exponentials to solve it. If I give you an equation with exponentials, and we use logs to solve it. So it kind of goes hand in hand. It's kind of with addition and subtraction, the same kind of relationship. Okay. So what I want you to do is take a look at example 1. And what we are going to do is it says log base 3 of x minus 5 is equal to 4. So the big important piece to this puzzle here is going to be that base. All right. So if it is base 3, let me get my stylist working here. Hopefully we can get this going. Okay. What I want to do is I want to use a base 3 for both sides. Okay. So what I do to one side, I do to the other. Now, I'm going to say 3 to the log base 3 of x minus 5. So 3 to the left-hand side of my equation. Hang on. My computer's a little frozen. All right. Let's see if we can get this working again. Sorry about that. Let's see if we can get this going. Okay. And then it would be 3 to the 4th. So if you notice, the left-hand side of my equation is now the exponent on the left side, and the right-hand side of the original equation is the exponent on the right side. Okay, so now I mentioned that logs and exponentials are inverses. If the base of your power matches the base of your log, those cancel, and I'm just left with x minus 5 equals 3 to the 4th. Okay, now I'm going to use my calculator on the left-hand side. I'm going to say 3 to the 4th power, and we're going to see what number that is. That's going to be 81. So to finish this off, I'm going to say x minus 5. Instead of 3 to the 4th, we know that's 81. And if I add 5 over to the other side, I know then x has to be 86. Okay, and that would be your final answer. So again, we're using logs or exponentials to solve log problems. So we're going to do it the same way for example 2. Now in example 2, I added something a little extra here. If you notice, there's a 4 out front. Okay. Now this 4 is a coefficient. We want to isolate the log first. We want to get that all by itself before we do anything crazy. So my very first step here is going to be to divide both sides by 4. And what that's going to do is it's now going to give me the log base 7 of x plus 1 is equal to 2. Okay, because 8 divided by 4 is 2. All right, so now we take a look at that base. That base is 7. All right, so that means I'm going to have to say 7 to the exponent of the left side is going to equal 7 to the exponent of the right side. And again, we always use the same base that was given to us in the beginning. So what happens here is these cancel, and on the left-hand side, we're just left with the x plus 1. On the right-hand side, we're given 7 squared, and you guys might know that already, but 7 squared is going to be 49. And then if I subtract 1, I get x to be 48. And that would be my final answer. Okay, so isolate the log, and then we're going to get rid of the log using powers. All right, so example 3. All right, again, we want to isolate that log. So I'm going to subtract this 2. Let's get this log all by itself. So on the left-hand side, I just have log of 2x. 5 minus 2 is 3. Okay, now from an earlier video, you might remember if there's no base written, this is really log base 10 of 2x. Okay, so if there's no base, that's always a base 10. So what base do I have to use when I use my powers? 10 to the left side and 10 to the right side. Now, if you have 10 to the log base 10, these cancel. And what I'm going to get is I'm going to get a 2x is equal to 10 to the power of the right-hand side, which is 3. Okay, so we need to figure out what that number is. I'm pretty sure it's going to be fairly large. 10 to the third power is going to be 1,000. So I have 2x is equal to 1,000. I'm going to divide the 2, and I get x to be 500. And that would be the answer to my question. Okay, so isolate the log, then use your exponential powers to get rid of that log and solve for your variable. Okay, all right, I got one more here for these type of questions. So again, we want to isolate this log. So I'm going to start, actually, I'm going to use my red pen here. I'm going to start, I'm going to add 11 to both sides. So I have 5 natural log of x is equal to 20. I then want to divide by the 5. So that gives me the natural log of x is equal to 4. All right. Now, you might remember from an earlier video, natural log is the same thing as log base e of x. Now, e in math is a fancy number, okay? There is actually an e button if you look at the screen. It's the division symbol. It's in blue right above the division symbol. So what I want to do is I want to say e to the power log base e of x is going to equal e to the fourth. These cancel, so I get x is equal to whatever e to the fourth is, and that's going to be a decimal for sure, but we're going to find out. So e to the fourth power is going to be approximately 54.598, and that would be my answer. Okay, now that's rounded, of course. Okay, when you have e in general is a decimal, so anything that involves e is typically going to be a decimal answer. All right. So the first 4 examples here, I gave you logs. We used the properties of exponential functions to solve them. Now, we're going to go the opposite way. I'm starting with an exponential function, and we're going to use logs to solve it. And that's what the purpose of what logs are. That's the new idea for this unit. Logs can solve exponential equations. Okay. Now, if you notice, I have 3 to the x minus 4 power. I cannot add that 4 because it's stuck in the exponent. So what we need to do is we need to get rid of this exponential power. The base is 3. So what I'm going to do is I'm going to say log base 3 and log base 3 of the left and right hand side. Now inside the left is just the left hand side of my equation, and on the right is the right hand side of my equation. When the log, the base of your log matches the base of your exponential function, those cancel. Okay, so these cancel out, and I'm just left with the exponent. And on the right-hand side, I have log base 3 of 27. Now, we need to figure out what this decimal is going to be. So I'm going to show you a few ways on the calculator. I did this in a previous video. But if you hit the math button and you go all the way down to the bottom, okay, there's a menu here. It's called log base. And when you press that, you can actually type it in, log base 3 of 27. Okay, and that gives me the answer of 3. Now, there is another way to do it. If you notice, there's a log button, but it requires a couple more button pushes. So if I hit log of 27, so always of what's in parentheses, divided by, hit the log button again of the base. And what that does is that puts the base in there for you. So log of 27 over log of 3 is still 3. So if you don't have a fancy calculator, you can still do this on any scientific calculator. But what I know is I know x minus 4, log base 3 of 27, we just set on the calculator is 3. So if I add that 4 over to the other side, I know x is going to have to be 7. Okay? So let's do another one of those. We're going to do some practice. Okay, the first one's always a little scary. So what we're going to do here is we're going to subtract the 5. Let's isolate the exponential. So I have 4 to the 3x is equal to 62. Okay? Now the base of the exponential is 4. So I want to use a log with the same base. So now I have 4 to the 3x inside that log. And what I do to one side, I have to do to the other. Okay. And we know that those cancel. And I'm going to be left with 3x on the left-hand side. And we need to know what that decimal is going to be on the right-hand side. So I'm going to hit math, log base. I know the base is 4. And I know I'm taking the log base 4 of 62. Now, we do get a decimal here, and that's okay. So I get 2.977. Okay, and then to finish it off, all I would have to do is divide by the 3. So if I divide this by 3, so on the calculator, I get x to be 0.992. Okay, and that is my answer. Okay, so 2 more. Okay, you can see them right here. Feel free to pause the video if you need to. So I'm going to do the same steps. I'm going to subtract the 9. So I get 6 to the x minus 2 is going to be equal to, let's see what that's going to be. 225 minus 9 is going to be 216. All right. So then I want to use a log base 6 because I have an exponential of 6. And I'm going to do that to both sides. All right. I know those cancel. So I get an x minus 2. Now I want to do a log base. I'm going to use that feature of my calculator. 6 of 216. Okay. And that's going to give me 3. Now if I add 2 over to the other side, I get an answer of 5. Okay. And then the very last question, I put an E in there just to remind you what E looks like. Okay, E is a number. I know it's a letter in the English class, but in math, it's a number. So what we want to do is I want to take that E, and to get rid of it, I'm going to use log of the same base. And the log base E is written as natural log, ln. Now, if you take the ln of E, those cancel. So 2x minus 1 is equal to the ln of 50. Now there is, on your calculator, if you look at the left-hand side of the screen, the natural log button is on your calculator. So I can say ln of 50 is going to be 3.912-ish. I can then add 1. So we'll do that on the calculator. So if I add 1, I'm going to get, now I'm going to kind of give myself some room. I have a 2x is equal to a 4.912. And then if I divide that by 2, I get x to be approximately 2.456. Okay, so that concludes our lesson on solving basic logs and basic exponential functions. So quick review. So a little summary here. If I give you a log, all right, so in example 1, I give you log base 3. I had to use a 3 to turn it into an exponential function. So we don't ever use logs to get rid of logs. We use powers to get rid of logs, okay? Now, on the other 4 examples or 3 examples, I started with an exponential. That is when I'm going to use the log feature of my calculator to solve. And in this case, if I take the log base 3 of both sides, then that gets rid of my exponential function, and then I can just add, subtract, or solve whatever is left. Okay, I hope this helps. Again, our success criteria is to solve basic logarithmic or exponential equations. There'll be an assignment for you to do on Google Classroom. Please let me know if you have any questions.